Hey, hello all. Welcome to my YouTube channel. In today's video, we are going to talk about ufuncs and broadcasting. Computation on NumPy arrays can be very faster or it can be very slow. How Python can be slow, you might ask. As you all know, Python is a high-level interpreted and dynamically typed language. So each Python operation comes with a small type checking overhead. Like other languages, we do not specify the data types while creating a variable. So let's say you do an operation a plus b. Okay, so Python has to check the type of a and b, whether it is a integer or a string, and all that, and finally it performs the a plus b addition. Okay, this is called type checking overhead. When you are running a small loop, it won't be an big issue, but when you are processing a large amount of data, it could be like 100 times slower. So yeah, when it can be faster, or and what are the broadcasting rules and what is u functions, is those are the topics we are going to talk about in today's video. So by the end of this video, you will be able to perform arithmetic operation in NumPy with the same or different size of arrays. So and also the you will know the broadcasting rules. So if you're new to my channel, consider hitting that subscribe button. Okay, the key factor makes NumPy faster is the use of vectorized operations. Generally, it is implemented through NumPy's universal functions, and those are implemented in C. Let me show you a loop in standard Python and the NumPy. Okay, let's import NumPy first, and I'm gonna create a variable with 10,000 elements. Shift enter, and I'm gonna add 5 to the each and every element. So I'm gonna say time it. This will give us the execution time. So let's say more Pythonic way is list comprehensive. I'm gonna say x plus 5 for x in a. Shift enter. Yeah, it is done. 65.9 microseconds. Okay, and let's perform the same operation in NumPy. So I'm gonna create a new variable np dot arange. I will say the same, or I can pass the same list. uh array and list a dtype equal to integer. Shift enter. I'm gonna use time it function and then say b plus 5. So you don't have to mention any loop here. By default, it performs operation in element wise. Shift enter. As you can see, it is 600 nanoseconds per loop. It is much faster. So yeah, this is one of the reason why NumPy is preferred for large amount of data processing and arithmetic calculation. Okay, now let's see what is ufunc. Ufunc is short for universal functions. So it is a special type of function defined within NumPy library that operates element wise on arrays. Okay, so let's say you have a variable a and np dot range, I'll say 4, and okay, our array has 4 elements now. Okay, it should be a range. I make this mistake all the time. Okay, so now our array has 3 elements, 0 1 2. So let's say I want to add 5. I will simply say a plus 5. This will add 5 to each and every element of array a. In the same way, you can perform subtract or a minus 5 or a multiply 5 and a divided by 5, and also a power 2. For power, you'll mention 2 asterisks and then 2. Okay, so if you want to perform all this operation in using numpy functions, yes, you can do that as well. Np dot add a comma 5, this will add 5 to each element, and np dot subtract a comma 5, and np dot multiply a comma 5. So all the values are multiplied with 5. So I will say add equal to subtract multiply, and for division we'll say np dot divide and a comma 5, this will be divide array by value 5, and if you want to get the power value, you can say power equal to np dot power and a comma, and let's say 2 power a power 2, yeah. Shift enter, and you will get a new array uh, with the new values. Like in this case it is like the new value will be a divided by 5. Okay, so yeah, not only the arithmetic operations, you can perform like a bitwise operation and trigonometry functions, comparison operations, all those are also universal functions, but in this topic we are not going to cover all those, so that will be covered in my future videos. Okay, so now let's perform arithmetic operation on two arrays. Okay, let's say I have an array np dot random dot randint, and date starting value 20, I'm gonna size 6, I'm gonna reshape this to 3 comma 2, shift enter, and b np dot random dot rand int 1 comma 20, size equal to 6 dot reshape 3 comma 2, shift enter. So now if I say a plus b, the operation has happened element wise, so this is what our a is and this one is our b is. So element wise operation has been done, and 15 plus 3 it is 18, and 10 plus 15 it is 25, and yeah, so on. So yeah, in this example, a plus b has the same shape and dimension. Okay, what if the shape and dimension are different? Okay, let's say I have an array c np dot range 3, a range it is, yes, I make this mistake pretty much all the time. So d, I'll say np dot a range, first I'll perform operation with 3 only. So c has 3 element and d has 3 element, and if I say c plus d, I get the output perfectly. Okay, so let's make a small modification to the array d now. So instead of 3, I'm gonna add one more element. Now the shape of my d is 4 and shape of my c is 3, so it is not equal. Let me perform an arithmetic operation now and see what happens. C plus d, I got an error. Operand could not be broadcast together with the shape 3 4. Okay, since the shapes are not equal, I got this error. Okay, let me perform one more operation with a different shape and see, let's see how it works. This time I'm gonna create np dot random dot randint 1 comma 20, size equal to 6, and I'll reshape this to 3 comma 2, and I will create one more variable. Okay, np dot array, this time I'll say 1 comma 2. Okay, so these two arrays has a different shape and dimension. Okay, let's see how arithmetic operation works on these two. Okay, so e plus f, shift enter. So it works perfectly fine, though the shape and dimensions are not equal. How did this happen? Okay, so this is where the broadcasting concept comes into picture. Okay, broadcasting is a term used in NumPy for performing arithmetic operations. I mean, pretty much all the universal operations on arrays of different shapes and dimension. However, like it won't work always. It follows a strict rule. Only when all the rules are satisfied, operation is allowed. Otherwise, we get an value error. Okay, let's see what are those rules are. Okay. Okay, so these are the broadcasting rules, okay, through which the broadcasting is implemented at the back end. So will not be able to see these implementation. So, however, like when you are performing arrays of different shapes and dimension, you can like validate whether it is compatible or not, whether the operation can be performed or not. Okay, so let's see few examples, and yeah, you will understand it better how the broadcasting works. So let me say I'll create a new variable g, np dot once. I'm gonna say shape 3 comma 2, shift enter, and I'm gonna create one more variable, one more array with a range. I'm gonna say 2. Okay, now these two array has a different shape and dimension. Let me display the shape, and h dot shape. As you can see, the first array has a shape of 3 by 2, and it is a two-dimensional array, and the second array has a is a one-dimensional array, and it has a two element. Let me display it. So g and h. Okay, now let's see how the broadcasting is implemented on these two arrays. Okay, so let me now g equal to, that is g guys, and 1 1 1 1 1 1, and our h equal to, which is 0 and 1, 0 comma 1. Okay, so in this case it is 3 by 2 array. So this one is one dimensional with two elements. Okay, okay, so let's see how broadcasting works on this. So I will check the rule 1. Rule 1 equal to, so if the two arrays differ in their number of dimensions, the shape of the one with fewer dimension is padded with ones on its leading side, left side. Okay, so in this case, let me write 2 here. The first array 3 by 2, and the second array has the fewer dimension in this case, so it will be padded with 1. So 1 comma 2. Okay, so it is done, and still the shape is not equal. So let's move on to the second rule. If the shape of the two arrays does not match in any dimension, the array with shape equal to 1 and that dimension is stretched to match the other shape. So in this case, so let me apply the rule 2 here. First one is 3 comma 2, and second one is 1. As per the rule, this will be stretched to match the shape 3. So that's what we understand from the rule 2. So I will say 3 comma 2. So you might ask, we have only one element, one row here, how this can be stretched to 3? So at the back end, this is how the operation happens. So 0 1, this is our first row. This will be duplicated two more times. 0 1 0 1. So in this way we have the same shape and the dimension, so we don't have to check the third rule, we can directly implement this. So here 1 1 1 1 1 1. Okay, so if I add these two, if I perform arithmetic operation on these two, I get an output 1 2 1 2 1 2. Okay, let's go check the output in the Jupyter notebook. Let me perform the arithmetic operation g plus h. Okay, now we got the same output. So that is how the broadcasting is implemented. Okay, let's see one more example where we have to stretch the shape in both the arrays. Okay, so let's say I'm gonna create one more array, I equal to np dot arange. I'll say once 3 comma 1, shift enter, and j equal to, I'll say arange 3. Okay, np dot arange it is. So I have it is a two-dimensional array with 3 rows, and in j we have 3 elements. It is a one-dimensional array. So let me show you the shape also, and j dot shape. So the first one has 3 1 and the second one has only 3 element. Okay, fine. Let's go back to the our whiteboard. It's a whiteboard. Okay. First it is I. Okay, I, we have the value vertically 1 1 1. Okay, and j we have horizontally 0 1 and 2. Okay, so the shape of these two arrays are 3 comma 1. Oops, sorry. Okay, 3 comma 1, and this one is 3 elements, one dimension it is. Okay, so these are not in equal shape or dimension. So let's see how broadcasting works on this. Let's go to the rule 1. So whichever has a fewer dimension will be padded with 1. Okay, so 3 comma 1, and here 1 comma 3, we have added 1 on the left side. Okay, still the shape is not equal. Okay, let's move on to the second rule now. Okay, rule 2, and here it is 3, still the shape is not equal. So wherever we have 1, that can be stretched to match the shape of the second element, a second array. So in this case it is 3. So in the same way we'll upgrade the shape in the second array as well. So it is 3 and 3. Okay, so in this case let's see how the uh, memory copy operation happens. Like say initially we have okay, we'll write this down 1 1 1. So we have stretched the second value to, which is like a column, yeah, value of our column, so that we have stretched to 3, right? So we have to add additionally 2 more column with the same value. Okay, now this one is first array, and let's see how the second array works. So now we have 0 1 2 here, and as you know, the first one is for row, the second one is for column. So we stretched the row element, so we have to add 2 more rows with the same value, 1 2 0 1 2. So now we have the same shape and dimension, so we can perform arithmetic operation on this. So if we perform arithmetic operation, we get an output. So let's say 1 1 1 2 2 2 and 3 3 3. So this would be the output of our uh, I plus j array. Okay, let's see how what we get in Jupyter notebook. So I plus j, see 1 2 3. So that is how we the broadcasting operation happens behind the scene for arrays, where it has to stretch the element in both the arrays. Okay, now let's see one more example where we cannot implement broadcasting. Okay, so let's say np dot k, I'll say np arange, I'll say 6, and I will reshape this to 3 comma 2. Okay, I'll create one more variable, and this one I will say only 3. Okay, so now this is what we have. L. Okay, let's move to the sideboard, and okay, 0 1 2 3 4 5. So our first array has 0 1 2 3 4 5, and our second array has 0 1 2 0 1 2. So this one is k and l, k l, and the dimension is 3 comma 2 here, and here it is 3. Okay, let's apply the rule 1 now. So rule 1 is we have to, the fewer dimension will be padded with 1. So here 3 2, and the fewer dimension is the second array, so we'll pad that with 1 1 3. And okay, still the shape is not same, so let's move on to the rule 2. Rule 2 equal to we have to stretch the 1 to match the shape of this first array. Okay, so in this case it is okay 3, it is 3 comma 2. Okay, so 3 comma 2, and let's stretch it to the 3. Since the first value is row, I have stretched it to 3 to match the second array, and 3. As you can see, still it is the shape is not same. Okay, now let's move on to the third rule. If in any dimension the size disagree and neither is equal to 1 and an error is arised. So in this case broadcasting cannot be done. So if we run the perform the operation k plus l, we get an error. So yeah, that is all about broadcasting. Just keep those rules on mind. So when you're performing operation on arrays of different types and different shape and dimension. Okay, yeah, so that's all for this video. I'll see you guys in the next one. Thank you all.